Hello, good afternoon. Welcome to my channel. Today's problem is count of interesting arrays. So problem number is 2845. So we have given zero indexed integer array comes and an integer module and an integer k. The task is to find the count of subarrays that are interesting. Subarray is interesting if the following conditions are true. So let CNT count be the number of indices I in the range L to R such that num_psi percentile module equals to k. Then CNT percentile module is equals to k. So return the number of integers denoting the count of interesting arrays. So this is a problem statement and example question input is for example one. It is nums1 is 3 to 4 and module given is 2 and k value is given is 1. So like we have to check for every subarray it is interesting or not, if the subarray is interesting or not. We have to like given question see a count with the number of indices I in the range and such that num_psi percentile is equals to k. Then control CLT percent module is equals to k. So these are conditions that has to be followed. So if these conditions are true, we will count the subarray as interesting. And for this example, check we have given the explanation. So let's find out our code here. So iterating from I to j, I to length, I to nums length, and this is the j to nums length. So we are following a nested loop for subarrays. So we will count 0, I is equals to 0 and j is equals to 0. It will be the 3. So nums j will be 3. 3 percentile module. 3% module given is 2. 3% module is 1. So 1 is equals to 1. Yeah, it is equals to 1. So count will be increased. So count will be 1. And count 1 percentile module. So given here is 1. We have to if the condition is true, then this condition should also be true. So the count percentile module is equals to k. So then the result we will count that as interesting. So CNT value we have got here 0, we have got 1. So 1 percentile module 1. 1 percentile module 1 is 1 percentile percentile of 1 module of 2 is 1 only. So we have got the k is equals to 1. So here left side is equation is also 1. So this condition will be true and we will increment the count for I is equals to 0. So I is equals to 0 and now j will be 1. J will be 1. So here it will be 2. So for 2 percentile is 2 percentile 2 is equals to k. No, it is not. It is not. The count given count here it is 1. So 1 percentile module is 2. So it is equals to, so this we will increment this here count. So for 4 for j is equals to 2. We will count 4. 4 percentile 2 is 2 only. 4 percentile 2 is not is equals to k. 4 percentile 2 is 2 only. Yeah, it is equals to, it is not equals to k. So we will check this condition. This condition count is altered. This equation for count equals to 1. This equation is not satisfied. So result equals to, we will add the result. So for 1, then for 2 we will add. We'll count all the subarrays. So for any like n is equals to 3 for this number of the element length, the subarray length will be 2 power n. So we will get 2 into 3. 2 into 3 it is equals to 8. So if we are if we uh, try to do the operation. 3 is one array and 3 4 3 2 is one array. 3 2 4 3 to 4 is one array. So 2 is 1, 2 4 is 1, 4 is 1, and 4 is 1. Sorry, 2 4 we have got 6. So this is 2 power minus 1. So we have got how many? 3 2 6. We have empty one also. Sorry, 2 power 1 is 7. This one empty one and empty so subset or subset we can call it both. So these are 7 number of subarrays available in this array. So we will iterate both, and for the brute force approach it will not execute because we are taking. So suppose the array size is 10 power 5. So for one iteration there is 10 power 5, but we are doing 2 iterations of nums length. It will be 10 power 10. So it will be on the 10 power 8, no? So it will won't execute. So our optimized solution will be using the prefix and hash map. So this is our optimized solution. So this is also same kind of approach, but we will iterate one time only. See, we will iterating one time only. We are creating hash map and we are creating two variables count and equals. And check we will check if I percentile module equals to k. So equals plus plus. It is our base condition. So I percentile equals. So then we will calculate if it is whatever the value we are getting here. So equals percentile module. Equals percentile module. It is also it will be reminder and reminder minus k. We will do this also. So then we will add it to the count. If there is element already present in the map, it will return the original value. But if there is no element present, it will return 0 here. So count get or default, and we will add the reminder and increment the frequency of the reminder. So in this way, we will get the frequency, and we will add the input also. So this is the optimized solution. So we try to execute this one. I tried submitting this one. Yeah, this is a optimized solution. So this is only for one iteration. So our maximum input value for 10 power 5 it will execute in the range of the range 10 power 5. So that is the correct iteration. We can solve it 1 second. So this is the problem of the day. So please like the channel and subscribe to my channel.